Welcome back. Section 4.2 coming at you, the second video from Unit 1. All right, this is what you all signed up for. This is the attack on solving word problems. The biggest problem, I think, for us as solvers is to read a word problem and be able to represent a variable in there in a meaningful way, represent all the information that we can gather out of the word problem into something that involves that variable. I'm old school. I tend to use X a lot. So you're going to see that as most of my solutions progress. But if you want to use a different letter, that's fine. Okay, section 2, here we go. The notion of reading the problem and putting something on your paper that involves mathematics that has variables and constants for some of us is a taxing challenge. And again, as we alluded to in the video from the first part, sometimes I think it's on us as teachers to realize that it takes a while for all this learning to sink in. And I'm not sure that we've always provided you that opportunity or enough time to make that meaningful learning take place. But the challenge is what it is. We're going to read the problem. We're going to try to translate it into something algebraic and then solve and make sure we answer. A lot of books give credit to this problem solving process to a guy by the name of Polya. And you can read the slide. Again, I don't tend to read them to you, but you basically tear it apart. What does it ask me to do? Can I write something that involves an algebra equation? Can I do the processes necessary to solve that equation? And I'm going to challenge you at the end to make sure that you do answer the question. I'm not one of those check people. As I alluded to in the last video, I used to resent that as a kid. Certainly, it's out there, and if you're willing to check it, you can have a better feel for whether your answer is correct. All right, the biggest problem for I think a lot of folks is when you read a word problem, it's not like reading a Stephen King novel. You got to read it in bits and pieces. The screen mentions drips and drabs. Read until you figure out something, until you can use it in some meaningful way. And that's how I think you and I succeed in terms of approaching word problems for solutions. All right, next step, translate that thing, somehow get a variable in there, somehow represent something in relation to that variable. And this is the part. When you can get good at this, you're over the bridge. You are ready to attack the problems. I often tell kids, once the equation's up on the board, you don't need me anymore. So this is the process where the work takes place. All right, certainly this is pretty self-evident, but it's important for me to make certain that you go slowly enough so you don't kill signs here. A bad sign just torches your solution. So it doesn't do you have great skill and then -2 times 5 is 143. That doesn't help us. Step 4 for Paul, does your answer make sense? I mean, if the problem says how old's Aunt Sally and you got like -9, somewhere you're a miss. I don't think we cared about Aunt Sally 9 years before she was born. So if your answer makes no sense, go back. Maybe you made a cheesy mistake somewhere and you can fix it. You do want to make sure you answer the question. Try not to just say X equals 4. If the problem says how many nickels does Tammy have, Tammy has 4 nickels. A lot of you in past experiences have had the opportunity to write little sentences at the end, and that's fine. You don't need to write a novel, but make sure you've addressed the question that was posed. All right, so we got some just cheesy examples where you've got to take an expression and try to represent in a variable form. I don't care what letter. On the slide, everything's probably going to be X because Dell wrote the slides and Dell's an X guy. I thought this was a cool chart, so I included it. Again, I'm not going to read it to you, but it gives you some phrases and it triggers them out into the individual math processes, add, subtract, multiply, divide. So you can take a look at it sometime, grab some Doritos and check it out. I think most of the expressions are probably ones that you're familiar with, but certainly check it out. Okay, now the things for us to discuss. If you're adding or you're multiplying, nobody cares about order. If you want to impress your friends, you can say that addition and multiplication are commutative. That simply means order doesn't matter. So whether you write 2 plus x and I write x plus 2, we're both going to be on the same team. When you get around to subtracting, we got to take a little extra caution because the idea of who's first and who's second on subtraction matters a bunch. All right, so we'll watch as we get ready. All right, so here we go. First one just says a number increased by 21. Again, I'm going to pick X. So if you're increasing, we're adding. So that's an easy one. Second one says twice the number. Again, nobody's getting hurt here. That's just 2X. If you picked a different variable than X, you're just as good. Now be careful on this one because now subtraction showing up. And even though the 9 sits first, your eyeballs see the 9 first. Before you can have less than something, you have to have something. So be careful here. You're going to take a number and diminish it by 9. You're going to lessen it by 9. So the correct answer must be x minus 9. If you wrote 9 minus x, I get to mark it wrong with one of my cool red pens. All right, 5 less than 8 times the number. Again, that less is going to show up at the end. So you start with your 8 times the number and then diminish it by 5. All right, first slide straight through. 7 times the number. This time I'm going to call it n just to change things up. And then we're going to increase that by 5. Again, not too much heavy yet. 7 times the sum. The word sum's capped, so it's probably significant. This time the 7 is affecting a sum. So you're going to make sure that parenthesis shows up to indicate you wanted to add the x and the 6, then have the 7 have an impact on that end result. So those parentheses are in fact important. Number 7 says, let's take 8 less than the radius. Let's call the radius r. You've already had this song before. The less than comes in second. So it's the radius diminished by 8. Last one in this slide, 9 more than a half of the diameter. Well, if we call the diameter d, that's a half d, and then add 9 to increase. All right, a couple of words. Read the words, read the words. All right, Bob's train's going twice as fast as Frank's. Frank's goes X, or whatever the units are, miles per hour. So Bob's is just 2 times that, or 2x. Together, and this one's more of a problem for more kids. Sparky and his brother together have $50. Sparky's got X dollars, and you got to represent how much the brother has. Well, you know the total. The total for the two guys together is 50. So if you take the total and knock off what Sparky has, the rest is left for his brother. So make sure you catch the order on this. It's the total 50 minus X to represent how much is there for Sparky's brother. All right. 11. Hilda's got 6 more than twice the amount of money Harry's got. Harry's got X. All right, so first of all, you're going to say, well, I'm going to go 2x plus 6. If you would have written this 6 plus 2x, you'd still be okay. Remember, addition's pretty flexible in terms of order, unlike subtraction. All right, length is 8 units less than 5 times the width. If we represent the width as w, which is pretty clever, the length would be 5 times that, and then diminish that amount by 8. All right, so again, a lot of practice on subtracts. Make sure you're clean. It's time for word problems. All right, here we go. So the firsters are going to Vegas, which is a cool trip. All right, when we're there, we're going to rent a car. All right, the charge for the car has basically 2 components. It's a flat charge of $120 for the week that we're going to have it, and it's 10 cents a mile for every mile that we tend to drive. Okay, and the question says, at the end of the week, the charge for the rental car was $202. How many miles did the firsters drive? So a lovely little blue text box there keeps the problem in front of us. All right, it seems like we're trying to figure out how many miles they drove, so that's a pretty good representation for X. All right, here comes an equation for us to consider. Remember, it's 10 cents for each of those miles, plus a flat charge of $120, gets you to that total of 202. We'll subtract 120, and then we'll grab a calculator and we'll divide by 0.10. So again, we got an answer. We could check it. All right, a lot of times people do. It makes you feel better. Again, I'm a typical egotistical solver. I did it. It's right. So firsters drove 820 miles, and that would be the number of miles driven that would get us a cost of 202. All right, example 2. Waldo sells watches and alarm clocks at the flea market. Each watch is $9. Each alarm clock's $5. And he sold 35 items total. And he totaled sales 287, but he can't quite snag that PS5, which is a bummer because, you know, Walter's a big Gran Turismo kind of guy. All right, so we got to decide. Well, you could let X represent the amount of either one. I chose alarm clocks. All right, now you still have to have something to represent the number of watches. And the key idea here is that you know 35 total items were sold. So the number of items that were sold that were watches were 35 minus X, where X were the amount of alarm clocks that Walter sold. Now we're going to bring some value in. Each alarm clock was sold for $5, and each of the watches was sold for $9. So when we bring money in here, $5 for each alarm, $9 for each watch, and the total amount of dollars is 287. Distribute hits the 9. All right, there's your 315 coming in minus 9x. Combine like terms and then move the 315 by subtracting. Don't get nervous about all the negatives. They wash out on the end. All right, be careful. You now have a value for x. You know what x is. The problem said how many of each item did Waldo sell. So if you bail out here, you'll lose points. All right, so you know he sold 7 alarm clocks. All right, you go back and 35 minus 7 would represent the number of watches, and that's 28. Another word problem. So now we got Firster in there. He's teaching his 221 classes. The good news is nobody fails. The bad news is you have 4 different categories to represent in terms of unknowns. So the secret to this is to make sure that you realize that it's easiest if you get a variable someplace where everybody else seems to be based on that. So again, there's the blue text box to help us out. All right, you read along with me here. A's seems to be based on D's. The number of A's is 2 more than 2 times D's. If you go all the way back earlier in the problem, there were twice as many C's as D's. So C's is based on D's. There are 2 times more B's than D's. So it looks like a lot of your grades are based back on how that number relates to the, to the number of D's. So I might suggest we let X be the number of D's. Now, as it turns out, you could have put X out there for any of the letter grades. But I think if you get it to the better place, it's a little easier to translate the others, okay? So you see in the problem, it says there were twice as many C's. So number of C's is 2X. Number of B's, as you read the problem, says 2 more B's than D's. So that would be X plus 2. How about the A's? Well, how about the A's? The A's were 2 times or 2 more than 2 times the number of D's. So that's 2X plus 2. And if we put all of those values together, we know that there were a total of 34 students who received a grade. So there comes our equation. Simply adding each of those, how many A's, how many B's, how many C's. Now the parentheses that you see on the screen aren't really necessary. I thought they were cool because they broke things up a bit for your eyeballs. All right, welcome to combining like terms with Del. 2x, 2x, that's 6x. Combine a couple of plus 2's for a plus 4. Subtract your 4, divide your 6, and again, you've got a value for x. You're not finished until you represent how many of each particular letter grade. So that's your next challenge. Go back, you've already represented, so you know C's is 2 times x, that's 2 times 5. B's is x plus 2, that's 5 plus 2. And A's is 2 times 5 plus 2. So the final answer represents how many of each letter grade. All right. Going for the gusto, even more obnoxious than the last problem. So you got a whole bunch of people and they're out there catching butterflies. Okay, similar fashion, see if you can figure out who's based on whom. Try to get to that bottom of the relationship stack, and that's where you're better served, I think, playing X. So you say, all right, I'll read along. It says, Elise caught twice as many as Carly. Matthew caught 4 more than Carly. Man, if I stop right now, it looks like Carly might be a good place for X. So if you continue reading through the verbiage, if it looks like Carly's the guy or the gal, let's go ahead. Let's do it. Let's let Carly be X. Now you got to go back and through bit by bit. All right. So what do you got? Well, I know Matthew caught 4 more than Carly. All right. I know something about Elise. She caught 2 times as many as Carly. So there's Elise at 2X. I got ahead myself with Matthew. There's Matthew with X plus 4. He caught 4 more than Carly. Somewhere we got information about Jalen. He caught 5 more butterflies than Elise. Be careful. Jalen was related to Elise, not to Carly. So make sure you got Elise's 2X increase by 5 for Jalen. Ryan, he's got twice as many as Matthew, but Matthew was X plus 4. So I kept that in there. And if you want to distribute the 2 right now, you certainly could. I'll get that as we write the equation. Looks like we have one more player, and it's Haley. And she caught 1 more than Jalen. So again, if you want to combine that 5 and 1 right there and make it 2x plus 6, that's not a bad idea. I'll do that on the equation. In a similar fashion, I kept the groups because I thought it made it nicer to look at. You'll notice I did make that 2x plus 6 for Haley. All right, so I got a distributive property in there, looks like for Ryan. Then we got to combine some like terms and make things happen. So there's your distributive for the 2x plus 8 on that second person. That would be Ryan. Put all those x's together. Man, that's a lot of x terms. 2 and 2 and 2, that's 6, 7, 9, looks like 10 X's. If you combine the 6 and the 8 and the 5, looks like we got 23. Subtract 23 from both sides. All right, divide by 10. Again, the only issue that we got is the same one we wrestled with last time. Having X doesn't answer it. The problem said how many did each person catch? So here comes the big finale. We already know X is 2. So Carly's got 2. Elise's got 2 times 2 for 4. Matthew's at 6, 2 plus 4. Jalen's at 9, 2 times 2 plus 5. Ryan's at 12, 2 times 2 plus 4. And 10, 2 times 2 plus 5 plus 1. So there are the butterfly catching numbers for each of the participants in the butterfly experience. Again, the key to these problems, I think, is if you get to the bottom of the relationship stack and that's where you put X, it makes it a lot easier to read the verbiage and represent the other players in the problem. So that's example 4 coming at you for solving word problems. Good news for us, that finishes section 2. We'll be back soon with our third and final section for Unit 1. Thanks for playing. See you then.